Here in this question, it's just kind of a matter of being comfortable with the concept of similar triangles. And the reason I say that is because we're told that BD is parallel to AE. And what that means is that basically here you have one small triangle, this little one, and then you have a triangle right here. And these two triangles are similar. Reason being is that because these two lines are parallel, these two angles are equal. This angle is equal to this one since they're parallel. And then of course both triangles share, the little triangle and the big triangle both share this angle right here. So all their angles are the same, and we're shown right here that there is a common ratio between basically that there's a ratio between this side and this side. So we see that the big triangle is 3 to 1, like big triangle to small triangle, it's 3 to 1. What does that tell us about the rest of the sides? Well, so we're given this little 8 right here. And given what we just figured out, that means that this side of the big triangle should be 3 times larger than this sort of equivalent side of the small triangle. So if the small triangle is 8, that means the big triangle has to be 24. Now the only thing you have to be careful about is you got to just understand that this whole piece right here has to be 24, which means that this section right here, just from B to A, is actually only 24 minus 8, which is 16. So again, don't forget that it's not this that's 24, it's the whole side of the triangle that's 24, and that 8 is a part of that. It's sort of included in that. So now that we have these two sides, what are we looking for? We're looking for length CE. And we can figure that out one of two ways. Basically, now that we've already figured out the sides, you can just do Pythagorean theorem and find it on the big triangle. But what you can also do, and what I'm going to actually do here, because it's going to be smaller numbers, I'm just going to do Pythagorean theorem on this little triangle, and then just multiply that length by 3, because I know that these are similar triangles. I just don't feel like doing like 24 squared and then 18 squared and then square rooting that. So instead, I'm going to do so we know that a squared plus b squared equals c squared. So our a squared on the little triangle is 8. So 8 squared plus 6 squared is equal to, c squared. So that's 64 plus 36 equals c squared. This is 100 equals c squared, which means if we take the square root of both sides, we just get that c is equal to 10. And of course, when you take the square root, it's plus or minus, but since you can't have a negative length, it's just positive 10. So we know that CD, this little section right here, is actually 10. So what does that mean about the whole of CE? We remember that our ratio was 1 to 3. So if we just multiply this by 3, we'll get this entire length, which is of course 30. So length of CE is equal to 30.